Here's something that should make you sit up. For 80 years, mathematicians thought they understood a simple-sounding problem. Scatter some dots on a page and count how many pairs sit exactly the same distance apart. They were sure they knew, roughly, the most you could ever get. They were wrong. And the thing that proved them wrong wasn't a person. It was an AI model at OpenAI, and it cracked the problem by reaching into a completely different branch of mathematics that no one had managed to make work here. This isn't AI writing code faster. This is AI producing genuinely new knowledge. By the end of this, you'll know why that's a bigger deal for your work than it sounds. Let's get into it. The problem is about as old school as maths gets. In 1946, the legendary mathematician Paul Erdős asked a deceptively simple question. Take a number of points on a flat plane. How many pairs of them can be exactly the same distance apart? Say, exactly 1 unit. It's one of the best known problems in all of geometry, precisely because a child can understand the question and nobody could fully answer it. For decades, the best arrangement anyone found was basically a tidy square grid. And the prevailing belief, the conjecture, was that the grid was essentially as good as it gets. The number of matching pairs could only ever grow just barely faster than the number of points. Most experts in the field believed that was the ceiling. Then, during a set of internal evaluations, a general-purpose reasoning model at OpenAI, not a special maths engine, just one of their reasoning models, built a counterexample. It found an infinite family of point arrangements that blow past the grid, with the number of pairs growing by a real, fixed margin faster than anyone thought was possible. Here's the part that made mathematicians take notice. The model didn't just grind harder at geometry. It pulled in heavy machinery from a totally different field, algebraic number theory, with names like class field towers, and used it to generalize Erdős's old grid in a way no one had pulled together before. Princeton's Will Sawin later pinned down the exact improvement, around n to the power of 1.01, later pushed toward 1.03, and none of this was taken on faith. 9 mathematicians, including the field's medallist Tim Gowers, went through the proof and confirmed it holds. OpenAI published the proof and an edited trace of how the model reasoned. Gowers called it, in his words, a milestone in AI mathematics, and said that if a human had submitted it to a top journal, he'd have recommended publishing it without hesitation. So why does an 80-year-old geometry problem land on your desk? Because of what it signals about where AI capability has moved. Up to now, the honest mental model for these tools was glorified retrieval. They remix what's already been written down. This is different in kind. The model's edge here wasn't raw brilliance, it was breadth. It knew techniques across mathematics that no single human has time to master, and it connected 2 fields that experts kept in separate boxes. That's the real shift. AI's advantage isn't that it's smarter than your best engineer, it's that it has read everything. On a hard problem where the answer secretly lives in a field your team doesn't know, that breadth is exactly the gap it can close. And that has a very practical edge for you. Think about how this result happened. The answer to a geometry problem came from number theory. Now look at your own hard problems. That nasty database contention issue might really be a queuing theory problem. That capacity puzzle might be an operations research problem someone solved in the 1970s. The next time your team is genuinely stuck, it's worth asking the AI a specific kind of question. Not fix this, but what other field has solved a problem shaped like this one? Importing tools from somewhere unexpected is the move these models are now unusually good at, and most teams aren't using them that way. But here's the catch, and it cuts the other way. When the AI produced its answer, it was correct. But it was also messy. Sawin said plainly that a human wouldn't have written it that way. It took 9 expert mathematicians to digest it, clean it up, and confirm it was right. So the lesson isn't AI replaces the expert, it's the opposite. The more novel and clever the output, the more you need someone who can actually verify it. A clever solution you can't check is a liability, not an asset. As your team leans on AI for harder, more original work, your scarce resource becomes judgment. People who can tell when an impressive-looking answer is quietly wrong. And keep the hype calibrated. This same model only cracked the problem about half the time, even when it was given maximum room to think. One mathematician admitted he'd considered the very same approach himself and gave up, because it usually leads nowhere. The AI didn't have a flash of genius no human could have had. It had the patience to chase a tedious path most people abandon, and the breadth to know which path was worth chasing. That's genuinely valuable. It's also not magic. From start to finish, this was a human-AI collaboration. So where does that leave you? 3 things. First, update your mental model. These tools have crossed from only summarizing what's known into occasionally producing what isn't. On the right problem, treat them as capable of real novelty, not just autocomplete. Second, put that to work. When you hit a wall, use the AI to go cross-domain. Ask what other field has already cracked a problem like yours. That's where its breadth pays off, and it's the part most teams are missing. And third, invest in verification, not just generation. The teams that win with this won't be the ones who generate the most. They'll be the ones who can tell quickly whether a clever answer is actually right. Here's the line to hold on to. For 80 years, the smartest people in a field were certain they'd hit the ceiling. A machine showed them the ceiling wasn't there by knowing something they didn't. The job now isn't to outread the machine. It's to be the one who can tell when it's right. That's Daramatic. We cover AI and IT practically for the people doing the work. If that's useful to you, like and subscribe. It genuinely helps us reach more IT pros. See you next time.